So in this lecture, what we are saying is, what is the relation between height and node of binary tree? Again, binary tree, and we are focusing mainly on binary tree. This is not a strict binary tree, let me tell you that. Again, till now what we have discussed, we have given introduction to trees, there everything, every keywords we have learned. After that we went to binary tree, and we discussed about how many number of binary trees that you can form with n is given, when n is given. Okay, right. Now, what is the relation between node and height? That is what our discussion is in binary tree. Okay. Now, imagine I have n h is equal to 1. That means I can reach till height 1. That's it. So tell me, minimum number of node that you need to reach h is equal to 1. Obviously, you need only 2 node. Minimum 2 node you need, right? You know, 2 node. So minimum, what you this is minimum. Let me take it as minimum. Minimum number of nodes. Minimum nodes I need to reach h is equal to 1. Then let me take it as maximum nodes that I need, right? So minimum node is what? Minimum node is 2, right? 2. What is the maximum number of node that I required? So I will draw it. So here I reached height 2, 1, right? Is 0 and 1. So I reached height 1. So the maximum number of node I required is 3. Okay. Now let us go to when h is equal to 2. I can reach till node 2. So what is the minimum number of node? This is minimum and this is maximum. Minimum of number of node to reach height 2. So I will draw left skewed tree. You can draw right skewed tree, or you can draw we have discussed, right, for n is equal to 3. We have discussed we can draw like this. So anything you can draw. Let us draw a left skewed tree, and the minimum number of nodes that are required is 3, right? Okay, 3. What is the maximum number of node? So let me draw this binary tree. So this is, now I reached height 2. So the number of node that was required was 7. Maximum number of node that was required was 7. So now we have drawn this thing. So let us see the relation. So the minimum number of node required is so much easy. Do h plus 1, that's it. If you want to reach 1 height, then you need h plus 1, that is 2 nodes. If you want to reach h is equal to 2, then you need h plus 1, that is 3 nodes. So minimum number of node that I required, that is n min, let me take it as n min, that I required is h plus 1. So what is the maximum number of node? So for that, what I will do is, I will take for h is equal to 2. So how, in this level, how many number of nodes are there? 1. Okay. In this level, what is the number of node I have? 2. Okay. In this node I have 4 nodes, or else I can take it as 2 power of n, 2 power of 2, right? So this is 2 power of 1, right? So this is 2 power of 0, right? 2 power of 0 is what? 1. So I will take it as 2 power. So it takes 2 power of 0 node, right? Yeah, in first level I have 2 power of 0 node. So this is what I will get. So if you extend a number of nodes, then it will go on like 2 power of 3 node, right? See, example, I will draw again all the nodes for this. So I will have 8 nodes in this level. So 2 power of 3 is what? 8. So again, this is simple. Let me, now I need to add these things, right, in order to get how many nodes. So n max will be what? N max will be, it will go from 2 power of 0 plus 2 power of 1 plus 2 power of 2 in my example. So in general, let me write it as if h is equal to 2, I am reaching till 2 power of 2. So if h is equal to n, for example, so for h is equal to 3, I will reach till 2 power of 3, right? So till where I will reach? Till 2 power of n I will reach, h, that is 2 power of h I will reach. So you know geometric progression. What is the formula? What is the structure of geometric progression? It is a r power of 0, right, plus ar plus ar to the power of 1, that is 2, right? It can go till a r to the power of k. This is what you know, right? This is what you know. So let me reduce this. What is the formula if you do this addition? It will be simple. You will be learning, you would have learned this in your PU or even in 10th. A into r power of k plus 1, k plus 1 minus 1 divided by r to the power r minus 1. So a into r to the power of k plus 1 minus 1 divided by r minus 1. So in this case, what is a? If you observe, a is 1 actually. A is becoming, so how to find r? Again, this is also basic thing. You need to take first element divided by, so the you need to take an element and you need to divide by previous element. Let me take this. How to find r? R is nothing but a r square divided by previous element is what? This one. So a r will give you r. So I am getting r. That means I need to do, let me erase this. So for previous, for this expression, let me find r. R will be again simple. I will do 2 power of 2 divided by 2 power of 1, or 2 power of 1 divided by 2 power of 0. So anything is fine. 2 power of 2 divided by 2 power of 1 will give me 2. So r is what? 2. So a is what? A is 1. Already I said a is 1. See, a is 1, 1, 1. This is just multiplying by 1. Okay. Now let me, for this expression, let me add, let me substitute. A is 1, 1 into r is 2, 2 power of k is what? H, right? H. Here it is k, here we have h. So h plus 1 minus 1 divided by r is 2 minus 1, that is 1. So what is my formula for n max? For n max, my formula is this. Let me reduce further. Let me reduce this further. So if I reduce, I will get 2 power of h plus 1 minus 1. So this is in n max. So what is the range of n max? What is the range of h? So it can be less, it can be greater than equal. This is not h, this is n. Okay. Now it can go, meaning what is the minimum value, minimum node that you can have? You can have h plus 1. That is what the minimum number of nodes that you can have. The maximum number of nodes that you can have is 2 power of h plus 1 minus 1. So this is the thing that we need to remember. So again, we have made a relation between h and n. So for h, what I am going to write here, right? For h, what I am going to write, I will show you in diagram by writing tree, because you can't simply like substitute these two things, right? Let me show you how it works. Let me I need to find h. That means they have given me number of nodes. I need to give them what is the maximum height that you can go, what is the minimum height that you can go. So imagine they have given me n is equal to 3. N is equal to 3. What is the maximum height you can reach using this 3? So I can reach, so I will take only one node in each level, and means height will reach to maximum height h max will reach to what? It will reach to 2. Okay, for what h min is what? So what I will do is I will take like this. So h min will be equal to 1. H min will be equal to 1. So from this diagram, what you can observe is h minimum is 1. That means h max is what? 2. So what is the relation between them? So h is equal to n plus 1, right? N plus 1. This is the maximum height that I can reach. Max can be of h plus 1, right? What I am doing? Sorry, this is n plus 1. Okay, n plus 1. If n is equal to 3, then height what I reached was 2. So h will become n minus 1, right? Sorry, n minus 1. So n minus 1. So if you observe this here, if you just push 1 at this point, you will get the maximum number of height. So what I take like this, h plus 1 is equal to n. So h is what? This is n plus 1. So maximum height that you can reach is what? N plus 1. So similarly, if you take this one, this will give you minimum number of height that you can reach by using n. So let us do. So first of all, let me take this complete thing here, so that will be easier for us. Copy this and let me paste this here. Then this is 1 h here, 2 power of h plus 1 minus 1. Okay, for h max I got x max is nothing but, you will consider these two things. So if we consider, I will get n minus 1. N minus 1, this is n. Again, for h min, I will consider these two things. So it is logical, right? It is logical. H min, I will consider this thing. Before that, let me write this expression and find h min. So this expression is n is equal to 2 power of h plus 1 minus 1, right? Minus 1. So send 1 that side. N plus 1 is equal to 2 power of h. How to send this to this side? Simple, log to the base 2, right? Log to the base 2. Just we have did this in our high school. So log base 2 of n plus 1 will be equal to h plus 1. So I will send 1 that side. So h will become log 2 n plus 1 minus 1. So this is the minimum height that you can reach. So for let me generalize this one now. I will copy this again. So let me turn on the charge. Now, and for h min and h max, I know the formula. So for n, what we got is this. So for h, what is the formula? For h, the h min is what we got is log 2 n plus 1 minus 1. So h max is what? N minus 1. So this is what these two expressions are so much important, right? So in next video, what I'm going to cover is, I'm going to cover relation between internal node and external node, right? So let me end this video.